We had several examples similar. What do we do?
X squared plus 2xh plus 2h squared.
Careful. It has radicals. How do we determine limits of rational functions? Forgive me, of functions with radicals in them. Here's your hint.
From the denominator. You reverse them.
You mean I multiply by the conjugate? The square root of x plus h. No, I cannot reverse. The square root of x plus h plus the square root of x. We've done this before, correct? Please go back and redo your notes. I'm begging you to redo your notes and take notes again. Good. So can anyone give us the numerator in the limit? Do not drop the limit operator. We are not there yet. I'm going to copy the denominator. And can anyone multiply these two for us and tell me what to write here? This isn't new at all, right? Yes, ready?
X plus h minus x.
That's it. As expected, these two are going away. Then we have the limit as h approaches 0, h over h, the square root of x plus h plus the square root of x. And now what is the second step that has to happen? If it doesn't happen, something is terribly wrong. What is my next step here?
Cancel the h's out.
Of course. And now please apply the limit and give me the final answer. Now the limit operator is gone because we apply it. So what is the answer?
You're wait. Yeah. Yeah, 0 because 1, 1, 1.
0 and 1 over 0, but it's not undefined.
Now 1 over square root h. I cannot see. Text. Text name is I can't see your paper.
Just go to view. Go to view and change it to the speaker.
Is it 2 square root of x?
That's it. Absolutely. The numerator is going to 1. If you don't write the ones, then you're getting confused. Potentially, I don't know. So the numerator goes to 1. The denominator goes to the square root of x plus the square root of x, which is 2 the square root of x. So this will go, we are going to carve this in stone. Again, the square root of x prime equals. Anyone else would like to say?
I'm confused.
Okay.
How did you get 2 root x? Where did that h under the root go?
I'm applying the limit.
Oh my gosh.
That's okay. We are getting used to it. It's not easy. It's not, it looks like gibberish at the beginning. I know. So that's what I said. Let's apply the limit, which means h approaches 0. That's why I covered it. And then we have the square root of x. You should cover it with your finger. It's okay, or the pencil or whatever. The square root of x plus the square root of x is 2 the square root of x. So this is 1 over 2 the square root of x. So that's another thing that it's carved in stone. Okay, finally, we're not going to use the definition all the time. So we're going to look at differentiation. This is difficult. Finding the derivative using the limit of the difference quotient is not easy. We have easier methods, but we had to learn how to do this first and understand when a function is differentiable and when it's not. Oh, yes, I forgot. Can anyone give us the domain of the derivative? You already gave me the domain of the function. You said 0 to infinity. Brilliant. Can anyone now give us the domain of the derivative?
Go 0 to infinity.
What do I have to put here? This is clear.
Bracket on the left.
Parentheses.
Yes, of course. X cannot be 0. See the difference? Which means that this function does not have a derivative at 0. How come? Because the derivative is not defined at 0. Why? Well, let's look at the graph. So here's the graph of the square root of x. How come that the derivative exists at 4? Square root of 4 is 2. 2 times 2 is 4. It's 1/2. The slope here is 1/2. How come that I have 1 at 9? Yeah, the square root of 9 is 3. 2 times 3 is 6. The slope here is 1/6. But how come that it does not exist at 0? Plug in 0 here. What do you get? Vertical. Yes, vertical tangent at 0. That's why. Which means this function does not have a rate of change at 0. Why? Because this function doesn't exist at 0. This will give this, which is this, will give the rate of change of this function at any point I want, but not at 0. It's not possible. It cannot give us anything at 0 because the derivative does not exist at 0. So differentiation rules. I know that this is what you're waiting for because no one wants to find a derivative doing this. No. Okay, so power rule. Do you remember when we differentiated x squared? What did we get?
(2x).
Exactly. Bring down 2, subtract 1 from the power. So then the general rule, x to any power n prime, what do you think? N goes in front, and we subtract 1 from the power. That's the power rule. Yes, I'll stop in a minute. I have 3 minutes. I'll stop in 1 minute so you can upload something. Okay, just give me, let's say, x to the 10th prime. Can anyone differentiate x to the 10th? Do you want to do x to the 10th with this? No. No, absolutely not. It will take us forever.
And x to the 9.
That's it. What if I have, and I stop, this is the last one. What if I have, let's say, 4x to the 10th prime?
50x to the 9th.
50 times x to the 9th power. And what is a constant, like 5? What is the derivative of a constant? What is the rate of change? If you have $5 in your pocket and you don't put anything in, you don't take anything out, what is the rate of change? Is it going up, going down?
0.
0. The rate of change of a constant is 0. It doesn't change, it's a constant.